Hello, this is Eric from UNC Charlotte. In distributed memory applications, blocking point-to-point communications have lower overhead and simpler semantics. But in many applications, non-blocking point-to-point communications are preferable. Blocking communications in MPI have simple semantics, but can be hard to use without causing deadlocks or performance issues. Also, using non-blocking communication enables an MPI process to perform multiple communications at once and to perform computation while the communications are happening. This can lead to additional performance in some applications. However, using non-blocking communication is not free. They require a higher overhead than blocking communications and the allocation of additional system resource. This can damage significantly your application's performance if one needs to make many small communications. From a semantic perspective, the send and receive buffers cannot be used until the communication is completed. MPI isend is the function to use to perform an asynchronous send. It takes 7 parameters. The first 6 are the same as MPI send. The last one is the address of an MPI request. MPI isend will return immediately, but the communication may not have happened yet. That MPI request will be used to determine that the communication is completed. Until the communication is completed, the sender process must not modify the content of the send buffer, as it could cause a race condition. MPI iReceive takes the same first 6 parameters as MPI receive. Notice that MPI iReceive does not take an MPI status object, since the communication will not have completed by the time the function call returns. Instead, it takes an MPI request, which will be useful to determine when the communication has happened. There are multiple ways to determine whether a non-blocking communication has completed or not. The simplest is by calling MPI wait. MPI wait enables a process to explicitly wait on a communication to complete. It takes the address of an MPI request to wait on, and the status of the request will be returned in the second parameter. Note that when a non-blocking communication is made, MPI needs to allocate resources internally for the request. These resources are deallocated by MPI wait. Let's look at a simple example. The sender performs a blocking send, and the receiver makes a non-blocking receive. When we run the code, the sender waits for some amount of time before executing the send call. But we can see that the receiving process returns immediately from the MPI iReceive call. Of course, the receiver cannot proceed past the wait call until the sender has posted the data. Non-blocking communication enables to post multiple communication at the same time, or it enables to reuse the communication time to perform some computation. Maybe a process needs to compute a piece of data A and receive a piece of data B. Then A and B are combined. With blocking communications, one could flip the order of A and B, but they would still need to be done one at a time, and it would take 3 seconds. But with non-blocking communications, the process can initialize the communication, and while the communication is happening, it can compute A. Because the communication and the computation overlap, the entire process only takes 2 seconds instead of 3. One does not have to wait for pending communications one at a time. MPI wait all enables to wait for all the requests in an array at once. It takes an array of requests and returns an array of statuses. MPI wait any enables to wait for any of the requests in an array. And if the process expects multiple requests to be completed, but not all of them, the process can call MPI waitSome. If a process wants to know whether a communication is completed or not, but does not want to wait for it to complete, it can use MPI test, MPI test all, MPI test any, or MPI test some. These functions work similarly to their wait equivalent. If a pending communication is no longer necessary, one can simply cancel it with MPI cancel. If a communication should be allowed to complete, but its status is no longer important, one can use MPI request free. Check the details in the man pages of any of these functions when you need them. Non-blocking communications can enable multiple communications to take place at the same time. and they also enable to overlap communication and computation. This is important in applications using manager worker systems, data flows, or pipelines. Applications that are expected to spend about as much time communicating as they spend computing will gain the most from non-blocking communications.